Good morning, grade 6 learners. Welcome to another Science Terrific episode here in Valenzuela FB Live. How are you today? I hope you and your family are all doing fine. Just a few reminders before we start. First, don't forget to type your complete name followed by the name of your school in the comment box. It will serve as your attendance for today, and in this way, I can acknowledge your presence in today's session. Second, if you want to participate in today's lesson by answering my questions, feel free to use the comment box. If you also have questions in mind, you can also comment it down below and I'll try my best to answer it later on. So today's lessons are based from the most essential learning competencies in Science 6. It is to describe the appearance and uses of homogeneous and heterogeneous mixtures. And at the end of this lesson, you, learners, should be able to define and identify solute and solvent in a solution. Infer through simple experiments the conditions that affects the formation of the mixture. So are you ready to learn now? Very good. So last week, we learned about mixtures. And when we say mixture, it is a combination of two or more substances that are not chemically combined. Since you are already familiar with the mixtures, can you please help me identify the mixtures here? So, first, is this milk a mixture? Very good. It is a mixture. How about the brewed coffee? Correct. Brewed coffee is also a mixture. Can you guess if the lemon is a mixture or not? Very good. It is not a mixture. How about the salt? A mixture or not? Again, you are right. It is not a mixture. Lastly, this bubbly mixture. Is this a mixture or not? So if your answer is a mixture, very good. Very good, grade 6. Thank you for helping me. You are all doing great. So we are now left with these three mixtures. What is common among these mixtures? Let us identify the substances being combined to form these mixtures. First one is the brewed coffee. What are the substances added together to form this? You're right. We have hot water and coffee granules. How about this toddler's favorite drink, the milk? Very good. We combined water and powdered milk. How about the bubbly mixture? What are the substances added to form this kind of mixture? Very nice. We have water and powdered detergent. And as you notice, when you added these three substances below with water, they all dissolved and created a mixture. When one substance dissolves into another substance, solution is made. So what is solution? Any idea? Solution is a homogeneous mixture in which components can no longer be recognized after they have been mixed, and it has uniform composition throughout. Solution is composed of solute and solvent. Solute is the substance being dissolved, and the solvent is the dissolving medium. So in a mixture of hot chocolate, the chocolate powder is the substance being dissolved, making it the solute, and water is the dissolving medium, making it the solvent. One example of solution is one of our merienda drinks, the iced tea. What are the components combined to form this mixture? Can you type your answers in our comment box? Correct. We have the powdered tea and water. Among the two, which one dissolves into the other? Very good. We have the tea as the solute because it is the substance being dissolved, and the water is the dissolving medium, which makes it the solvent. Now, I have acetic acid and water. Which is the solute and which is the solvent? Good job! We have acetic acid as the solute and water as the solvent. And if we combine the two, we can create one of the most important ingredients in our favorite dish adobo, the vinegar. Water dissolves almost all solute. But why some solute dissolves faster compared to others? So to answer this problem, let's have an activity. Are you ready to do some science terrific activity? Come and join me in exploring the world of solute and solvent. And in this activity, we are about to discover the factors that affect how fast a solute dissolves. In the first activity, what did you observe on the movement of the milk in the two setups? Powdered milk in set A moves and dissolves faster compared to the powdered milk in set B. What is the difference between the water in set A and the water in set B? They differ in temperature. Set A has hot water and set B has cold water, and as we observe the particles of powdered milk, almost all particles dissolve in set A with hot water compared to set B with cold water. Meaning, the temperature of the solvent water has an effect on how fast the solute powdered milk will dissolve. So the higher the temperature of the solvent, the faster the solute dissolves. Therefore, when creating an iced coffee, it is better to dissolve the coffee grounds in a hot water first before placing cold water and ice. In this activity, we use the same amount of solvent salt and water as the solute. But why the solute salt in set A dissolve faster compared to the solute salt in set B? It is because they differ in the rate of stirring. Mixture A stirred slowly, while mixture B stirred vigorously. So the rate of stirring has an effect on the rate of dissolving solute. The faster the rate of stirring, the faster the solute dissolves. This is why when you want your powdered detergent to dissolve in an instant, stir as fast as you can. In the third activity, what is the noticeable difference between the two setups? Very good. The size of the solute. The size of solute has an effect on the rate in dissolving mixtures. In set A, we use powder detergent, which is obviously smaller compared to set B with detergent bar, which is obviously has larger particles. The mixture in set A bubbled faster compared to the mixture in set B. This means that powder detergent as solute in set A dissolves faster compared to the detergent bar as solute in set B. So we can conclude that the size of particles really has an effect on how fast the solute dissolves. The smaller the solute particles, the faster the solute dissolves. This is the reason why when we put granulated sugar in an iced tea, it will dissolve faster compared to the same amount of sugar in cube. How did you find our activity? Don't forget to click like or heart this video if you learned something from it.
Things that are used at home are called household materials. Some solutions that we are familiar of are very useful in our daily lives. Just like this coffee. This is a solution that is part of our parents' breakfast. This dishwashing solution is used for cleaning. This perfume as part of our personal hygiene. And when we have wounds, we use this hydrogen peroxide to disinfect it, making it a medicine. These are just some examples of household solutions that are very useful in our everyday living.
So again, what are the factors affecting the solubility of the solute in a solvent? We have temperature, rate of stirring, and size of particles. So to check your understanding, I will give you an example and let us identify the solute and the solvent in the given solution. And let us tell what factor affects the solubility of the solute in a solvent. Are you ready? Show me your virtual thumbs up if you are ready. That's great. So let's start. First example, dissolving coffee with creamer in a water using a spoon or a stick. So in this solution, what is the solute? Type in your answers below. You are very good. The solute is the coffee with creamer because it is the substance being dissolved. How about the solvent? Type in your answers. You are correct. The coffee and creamer are dissolved in water. Therefore, water is the solvent. How about the factor affecting the solubility of the solute in a solvent? Type it down. Doing great, grade 6. The answer is the rate of stirring. You're all very good. You're all doing great. Another example, putting of salt into the hot sinigang soup. What is the solute in the given solution? Very good. We have salt as the solute. How about the solvent? The solvent is the soup. Very good. How about the factor that affects the solubility of the solute salt? Comment it down. Very good. The answer is temperature. The salt will dissolve fast because the soup is hot. Good job, grade 6. I'm so happy that you learned something today. So let us always remember that solute is the substance being dissolved and the solvent is the dissolving medium. The rate of dissolving of a solute in a solvent is faster when solute and solvent are stirred. The solvent is warmer or the solute consists of smaller particles. I know you still have something in your mind that you want to ask. This is the perfect time to ask your questions. Feel free to type in your questions below and let's wait for your questions. So I can see here one good question. Well, it says here, is it possible po to have solute in gaseous form? Yes, it is possible. And you know, the best example of solute in gaseous form is the carbon dioxide in our sodas. So the soft drinks that we are drinking is a solution with carbon dioxide as the solute and water as solvent. Thank you for that good question. Another question here is, what if I won't stir my mixture? Will it still be dissolved? Of course, yes, certainly. It will still dissolve. But it will just take a little longer compared when you stir it. So if you want your mixture to be easily ready, it is better if you stir it. So I can still see a lot of questions in our comment box. Please reserve those unanswered questions to your classroom science teacher in your follow-up discussion tomorrow. So please do not forget to attend your follow-up discussion. So before we end this session, I want to share to you this African proverb. If you're not part of the solution, then you're part of the problem. Always remember that in a world full of problems, let us always try to be the solution. Once again, I'm Ms. Sheila Jane C. Tesorero, your Science 6 FB Life teacher, always reminding you to stay safe, stay healthy, and stay indoors. See you again next week in another Science Terrific episode here in Valenzuela FB Live. Thank you for listening.